Welcome to our second video, ladies and gentlemen. Let's get busy with direct variation, lesson 5.6, page 200. I know you read it. You took a few notes. You probably brought back some memories of proportional relationships, and we'll talk about that in just a second. We're going to use the formula to the formal definition of direct variation today. How can you use a graph to show the relationship between two quantities? Probably wondering why we're doing this, and that is because I don't want you to ever hear direct variation and say, oh, I never heard of that before, knowing that it really is proportional relationships. So you should have taken some notes. Some of those notes taken should be, hey, direct variation has an equation. And that equation is y equals kx. And it even said right in the book where k is the slope. So I don't understand why they want to use k, other than that they think k defines that you have a proportional relationship, that you have a constant of proportionality. In other words, they're telling you if you have a constant of proportionality, that you have a proportional relationship, and that says two things. It has a constant rate of change, it has a slope, and it passes through the origin. Right? Which is 0, 0. So it passes through the origin. All these things we have learned, we just didn't know some of this vocabulary that they want to apply to it. Y equals kx. Notice that is in slope-intercept form. Y equals mx plus b. Y equals kx is in slope-intercept form. And what is the intercept? Right, it is 0 because it has to pass through the origin. And then what did they do? They took m and they made it k. Whoop-de-doo-dah. And they just want to give us more vocabulary that we have to learn. This is a language. Mathematics is a language, and there's a lot of things we need to know. So when we look at this graph, we see that it passes through the origin. We see that it has a constant of proportionality. It goes up 10 and over 2. So our 10 over 2 should be 5 over 1. Well, let's see if it goes up 5 and over 1. Oh, yeah, right there. Bingo. So our slope, our k, our constant of proportionality is 5. All right? Now, some people might wonder, could our constant of proportionality be negative? Well, yes, it could. It's not always positive. We don't always use the first quadrant. We could have something passing through the origin and come down at a constant of proportionality in this direction. You might think, well, where would that be? Well, I can't think of 1,000, but I can think of one specifically off the top of my head. An example might be, hey, I'm an ocean diver. So I'm starting at sea level, 0, 0, starting at sea level, and then I dive into the water, and after a certain amount of time, I go down at a constant rate. Make sense? So I could be moving in, I could have a constant of proportionality in quadrant 4, which has a negative k. It could be. Well, let's get to some of this stuff where we identify direct variation from a graph, and we have to remind ourselves of two things. One, it has a constant of proportionality, which is k, which we call a constant rate of change, which we call slope, all that kind of stuff, and it has to pass through the origin. So we take over here, I can see if it's a straight line, it does have k. It does have a constant. Well, I shouldn't say it has k, I should say it does have a constant rate of change. It does have slope. But I know it's not k because this is not proportional because it does not pass through the origin. So this one is no. So it can't have k. It does have m, but it doesn't have k because this is not a proportional relationship. The next one does, though, pass through the origin, and it has slope. So it does have k. It does pass through the origin. And so, yes, this is a direct variation equation. Slope, formula, graph. Let's just go on down the line. Nextly, we want to take, what if we look at an equation and say, hey, does this equation show proportionality? Does it show direct variation? Because I can write it in the direct variation equation where y equals kx. So in other words, if they give us an equation, we want to solve for y and see, do we have a constant of proportionality with it passing through the origin? Meaning there is no intercept. It is the origin. It is 0. So taking a look at number 7 here, y equals 2/3 x, is that in y equals kx form? Well, the constant of proportionality would be 2/3, and so yes, because it does not have an intercept. Well, it does. It's 0. It just doesn't show a different one. So it does pass through the origin. Coming over here to number 8, y minus 3 equals 4x. Solving for y, I would have to add 3 to both sides. So y equals 4x plus 3. Well, this intercept is not the origin, so there's no way that this is a direct variation equation. Number 9, negative 3y equals negative 2x. Again, solving for y, divide by a negative 3, y would equal 2/3 x. Well, that's exactly like number 1 after we solved it. So yes. And this is only 3 examples. There's a bunch of different ways they can write the equation. You just have to solve for y and see if after solving for y, this is what comes on the other side. Y equals kx, y equals mx, however you want to talk about it. Okay? And lastly, we're going to talk about, can we identify, direct variation from a table. I went too far there. From a table. So, well, once again, we have to know, does it pass through the origin? Does it have a constant rate of change? So we know the origin means that x and y are both 0. Well, if x is 0 and y is something else, it does not pass through the origin. So we know this is no already, just by looking at it. Does it have a constant rate of change? Sure, it goes up by 1 each time, and it goes up by 3 each time, but it does not pass through the origin. And this is a big key indicator right here. They gave us 0, -2, meaning it does not pass through the origin. It passes the y at -2. Going on to number 11, we can see that it doesn't give us 0, 0, but we do see that it does have a constant rate of change. X goes up by 2 every time. Y goes up by 1 every time. So we know the slope, the constant of proportionality, is 1/2. And we got to know, does it go through the origin? Well, the easiest way to figure that out is to say, hey, if I go back by 2, do I get 0? And if I go back by 1, do I get 0? And the answer to that is yes. So this is a table that shows direct variation. It has a constant of proportionality, and it goes through the origin. And number 12, number 12 helps us out right away, because in this table it does show us immediately that it passes through the origin at 0, 0. We just have to find, does it have a constant of proportionality? So y goes up, y goes down by 2, by 2. Uh-oh, then it goes up by 2. Uh-oh. And, well, let's see. X goes down, or goes up by 1, up by 1, up by 1. So this would be no, because we don't have a constant of proportionality. Going down, going down, going up. So this one is no. You got to be careful. You got to make sure you look at all of them. It didn't always go up, down by 2, so it does not have a constant of proportionality, even though it does pass through the origin. So we're done with our video notes for tonight. Ladies and gentlemen, our quick right number 2, does the graph show direct variation? And you can say yes or no. And then if you would, write down these 2 equations. What are you going to do? Solve for y to find out if they are direct variation equations. Then what I need you to do is write down any questions you have about slope and direct variation. Question marks, highlight, whatever it takes. Begin working on your assignment when you're done with your quick write. Remember, finish off your 45 minutes with aggressiveness and urgency. Use your time effectively. Be accountable. Make yourself the greatest self you can have. Ladies and gentlemen, you rock. It is a pleasure. It is an honor to be with you, and I will see you tomorrow.